Hi everyone, my name is Victoria Carthew and it's lovely to be joining your lessons this morning. Coming up in English, we'll be looking at how analytical images support the news. Our mathematics subject is Introducing Order of Operations, and in science, we'll explore the features of the moon and discover how space missions have helped us to understand it. Sit back, make yourselves comfortable, get your thinking caps on and let's get ready to learn. Why do reporters use maps, graphs and tables in their news reports? What do they add to the story? Would reports be the same without these images? Let's explore why these are used and look at an example.
Hi everyone, I'm Rebecca. News reports provide the reader with important information. They do this not only through the words they use, but also the images they include. These images are often called analytical images. Today, we are going to look at what analytical images are and how they can be used to give the reader more information. Before we think about images in news reports, let's briefly revisit what a news report is. After all, to think about the images in news reports, we have to make sure we know what news reports are. News is information about recent significant events or issues. Many different modes are used for sharing the news. The news can be presented in print, as an audio or visual broadcast, or on the internet. The purpose of a news report is to inform readers or listeners about a newsworthy or important event that has occurred. When you look at different news reports, consider the intended audience. So, who was it written for? Different media can target different audiences, for example, younger or older age groups. News reports have a set structure. The most important information is at the beginning, and information is presented from most important to least important. Think of it as an inverted pyramid structure. News reports often contain images, but why do they do this? Think about a news report you have read or seen. What sort of images did you see? You might see many different types of images in news reports. Images can be used in news reports to grab the reader's attention. People might want to stop and read a news report if they see an interesting picture or image. Sometimes an image can be more effective at getting the reader's attention than words. Images can also be useful for telling part of the story and getting a message across to the reader. A picture can quickly tell people what the news report is about and share some important information with the audience. Pictures can also be used by the reporter to gently persuade or convince the reader to feel something about the subject. One type of image that a reporter might use in their news report is an analytical image. But what is an analytical image? In factual texts, complex information and ideas can be presented in visual form. These are often referred to as analytical images and include diagrams, maps, labelled images, tables, graphs, and timelines. Analytical images that support news reports are used to communicate information to the audience. Changes to an image can influence the overall meaning of the news report and the point of view it supports. Let's have a look at our news report and the analytical image that is used to enhance this article. Take a moment to skim this article by looking at the whole text to get an overall view and remind yourself what it is about. Skim your eyes over the text features. Read the title of the report. Look at the layout of the text. Look at the picture for further supporting information. Remember, when you skim your eyes over the text, you are not reading every word. You might read the first line of the first and last paragraph. When you skim, your eyes move quickly across the page. From your skim of this text, you'll have remembered that this news report is about the fear Australians have about being attacked by sharks and why this fear may be unwarranted or unproven. Let's look at the image used in this news article. It's not a diagram, map, table, or graph. It's a labelled image of a shark and it's shown swimming in the ocean. This image is colourful and shows the audience what a shark would look like in its natural environment. When you look at the image of the shark, does it make you feel like sharks are dangerous or that you are under threat? This picture of the shark peacefully swimming in the ocean reinforces the idea that the ocean is the shark's natural habitat and that they are not a significant risk to swimmers. The image supports the message, the headline, and the wording in the news report. What would happen if different analytical images were used in this news report? Look at this analytical image. It is a table that gives us more information about some ideas in the news article. What does this table tell us? To help us understand the meaning, we need to read the caption under the table. It says, Table 1, Decline in Shark Population 2003 to 2010. I know that if something declines, its amount goes down or becomes smaller. So the table is about the drop in the number of sharks in the ocean. The caption also contains a time frame, 2003 to 2010. This means the table shows how much the numbers of sharks went down between 2003 and 2010. I can read the heading in my table to see that the shark species whose populations are declining are hammerhead sharks, grey nurse sharks, and leopard sharks. I can also see that I am being provided with the decline in a percentage. So reading my table, I can see that the population of hammerhead sharks decreased by 32% from 2003 to 2010. Would this analytical image support our news report? Using my knowledge of news reports, I can look across the body of my report, which contains facts, details, and quotes, and see that body paragraph 1 mentions these species of sharks. If I then look in body paragraph 5, I can see that some humans undertake activities, such as shark culling, that are causing the shark population to decline. Do you think this is a useful analytical image to give the reader additional information that supports the news report? I think it does. If I was scrolling through a news site and I saw this table, I would get an idea about what might be in the news report. It also builds my understanding about what is in the news report when I read it. What about this analytical image? What does it show us? This graph provides the same information relating to the decline in the shark population for the years 2003 to 2010. Either analytical image relating to the decline in the shark population, so the table or the graph, could support a point of view that the trade in shark fins and the culling of sharks will destroy shark populations. One analytical image could be seen as more persuasive than the other because it may make a clearer visual statement. Which one do you think is the most effective? Analytical images are images like graphs, tables, diagrams, and maps that are used in news reports to visually represent key information in the report. They can provide the reader with additional information and persuade the reader to have a particular opinion or view about a topic. If you are on the internet looking at the news or flipping through newspapers, pay attention to the images. What do they tell you? How do they help you engage with the news report? See you next time. Bye.
There there are some things in life that you have to do in a particular order. For example, you have to cook the dinner before you can eat it. This is the same in maths. To explain more, here's Annie.
Hi there everyone. I can't drink this water without taking off the lid first. And I can't eat this mandarin without peeling it first. Just like these things, in maths, we need to do calculations in a specific order to get the answer. Up until now, most of your calculations have involved only one operation, such as addition. Today, we're going to explore some rules when using multiple operations and use them to calculate expressions. Do you remember what an expression is? An expression is a combination of numbers and symbols. For example, 7 plus 6 multiplied by 4. How do we work out the answer to this? Do we add 7 and 6, which is 13, then multiply it by 4? That gives us 52. Or do we multiply 6 by 4, which gives us 24, and then add it to 7, which is 31? Which way is correct? Let's find out. When we operate with addition on its own, the answer is always the same, regardless of which addition is calculated first. For example, 4 plus 6 plus 9. 4 plus 6 equals 10, plus 9 equals 19. Or 6 plus 9 is 15, plus 4 is 19. They both equal 19. The same happens when you operate with multiplication on its own. The order in which we operate does not matter. But things are different when we look at subtraction and division. The order in which we operate does influence our answer. For example, 48 subtract 8 subtract 5. 48 subtract 8 is 40. Subtract 5 is 35. But 8 subtract 5 is 3. So 48 subtract 3 is 45. We get different answers. So the order in which you perform the operations makes a big difference. We see the same thing when we operate with division. So far, we've looked at expressions repeating one operation multiple times. We know the order doesn't matter when we operate with addition and multiplication on their own, but it does matter with subtraction and division because we've seen the answer change depending on the order in which the operations are carried out. Luckily for us, mathematicians have solved the problem of getting different answers to the same problem by developing a set of rules to follow, called the order of operations. When everyone around the world follows the same order of operating, we get the same answer to the same problem. The rules we need to follow are: calculate expressions in brackets, solve any multiplication or division working left to right, and solve any addition or subtraction working left to right. Because the brackets are always calculated first, we need to be very careful to have them placed carefully within the expression. Let's look at this example. Monty has 56 collector cards. He lost 12 cards. He shared the remaining cards among 4 of his friends. How many cards did each friend receive? Without the use of brackets, the expression would be 56 subtract 12 divided by 4. The order of operations would tell us to divide 12 by 4 first, but that is not what the problem is asking. Monty did not share the 12 lost cards with his friends. We need to add brackets to make the expression reflect the problem. Where would you put the brackets? Placing brackets around the 56 subtract 12, make sure that we do the subtraction first, and then the expression matches the problem. So 44 divided by 4 is 11. Each friend received 11 cards. Remember that you complete multiplication and division from left to right, and then addition and subtraction from left to right. Let's look back at the question from the start of the lesson. 7 plus 6 multiplied by 4. Well, there are no brackets, so we don't have to worry about that rule. We do have multiplication or division. This expression only has a multiplication, so we do that first. 6 multiplied by 4 is 24. Then we work left to right. So we add 7 to 24, which is 31. Today we explored order of operations to calculate expressions with multiple operations. Using these conventions means that everyone can write and solve expressions the same way, preventing any confusion. Think about when in your everyday life you have something to do in a specific order. And remember that this is the same as in mathematics. Thanks for joining me.
Now, if we're looking at the order of this show, then My Place is up next. Today we meet 2 First Nations students in our special segment, which celebrates kids from across the state of Queensland.
Watamoli.
I'm Linda.
And I'm Zong.
I'm 15 years old.
And I'm 16.
Our mob is the Jury people.
And this is the Jury Country.
We go to Bowen State High School. Bowen's part of the Whitsundays. It is known for its beaches and mangoes.
In my spare time, I either like to exercise or go to the beach with my friends.
My favourite subjects are humanities and maths. In this unit, humanities is talking about the rights and freedom in the Indigenous culture.
School is important to me because when I graduate, I know the knowledge of what I want to be as a marine biologist. We are looking forward to going back to school.
And we hope all you mob are doing well.
There's a program at the Queensland Children's Hospital called Juice TV, and each week it gives patients and their siblings the chance to star in their own show. They host their own segments or join the junior crew on location at the hospital. Let's join David from Juice TV to learn about robotic cars. David talks with Professor Michael from QUT Robotics. Professor Michael and his team have built some very cool mini autonomous cars that don't need a driver. Let's jump in and learn the important role animals played in the design of these robotic cars.
What's up guys, I'm David, and with me today is Professor Michael from QUT.
Hey David, it's so great to be here. Thanks so much for having us on the show.
Alright Michael, I read an article that described you as Dr. Frankenstein. What's that about?
I'm going to take that as a compliment. We make lots of robots in our lab, and one of the things we do is we copy lots of bits from lots of different animals. So maybe that's why the name came up that way.
You copy animals, how does that help you to develop robots?
Well, we humans think we're really good navigators, but really it's the animals who are so fantastic. And so we copy all sorts of different animals, rats, insects, to try and make our robots better navigators as well.
That's cool, but I've heard that there's a lot of things happening with autonomous cars at the moment. Why is that so important?
Autonomous cars could be really, really cool. Imagine a robot car that drives itself, doesn't get tired, never gets distracted, and is really, really safe. That would be a wonderful thing to have driving around our cities.
You brought one today, didn't you?
Yeah, we did. Do you want to go check it out?
Yeah.
And voila! This is our mini autonomous car.
Whoa, that's awesome.
It has a big LiDAR on the front. This is a laser that sends out beams all around the car. It's got a camera on the front, sees what's in front of the car. It's got a computer on board. It's even got a safety stop in case you need to stop it all of a sudden. So making an autonomous car is really challenging, and a lot of the work's been done by James, a PhD student in our lab. James, what are we working on today?
So we're just making our final touches to make sure that everything in our autonomous run runs nice and smoothly in these great outdoors.
Alright guys, let's talk some specs. What's under the hood of this bad boy?
So it's effectively just an RC car that we've hacked. So all the sensors that Michael mentioned before run through this just USB hub. They all go into this computer here. The fan keeps it nice and cool. And then on the back here, we've just got a router just so we can get into the computer every now and then. And then we've just got batteries, and other than that, everything is fairly standard. It's just your small-scale autonomous vehicle.
And this thing drives itself.
Oh yeah, it's pretty cool. How about we try it out?
Okay.
Moment of truth, guys. Here we go. 3, 2, 1.
How good is that?
Best yet, you can still drive it as an RC car. Want to take it for a spin?
Yes, please.
What do you reckon?
Pretty cool. Thanks so much, guys, for letting me drive this. I'm pumped about robots now.
Thanks so much for having us. We had so much fun. Anytime you want to come by QUT Robotics, just drop us a line and we'll show you around.
I'm David. This is QUT Robotics. I'll catch you later.
More science now. We're going to explore the features of the moon and discover how space missions have helped us to understand the moon. For thousands of years, people have wondered about the moon because they could see it from Earth. Did you know that it wasn't until 1969, 51 years ago, that astronauts were able to visit the moon? Even though the first moon landing was 51 years ago, we don't know everything about it. So scientists continue to study the moon and apply what they learn to life on Earth.
When we look up into the night sky, what do we see? If we're away from city lights, we see millions of stars, and sometimes we can see the moon. The moon isn't a star. It doesn't produce its own light, so why does the moon appear brightly in our night sky? It's because the surface of the moon reflects light from the sun. This image is what we see in the night sky when there's a full moon. However, we don't see a full moon every night. That's because the moon goes through a cycle of phases, so to us its shape changes over time, but it's really just how much of it we can see. It takes 1 lunar month, or 29.5 days, for the moon to pass through all of its phases, from full, shrinking down to nothing at all, and then back to full again. It might surprise you to know that, just like the Earth orbiting the Sun, the moon orbits the Earth. It takes about 27 days for the moon to go all the way around the Earth just once. Does every planet in our solar system have a moon orbiting it? I'm glad you asked. Astronomers, like the one at Parkes in New South Wales, can collect data about the solar system using radio telescopes. Let's have a look at some of their data to find out more. The first column on this table lists the 8 planets of our solar system in order of their distance away from the Sun, from Mercury all the way out to Neptune. The second column of the table shows how many moons each planet has orbiting it. Earth has 1 moon, Mars has 2. We can see from the data there are 2 planets, Mercury and Venus, that don't have any moons. Maybe you could think of a reason about why those 2 planets are the only ones with no moons. Notice the asterisk next to the number for the moons listed for Jupiter, Saturn, Uranus and Neptune. It's that little star next to the number. The asterisk means that scientists are not sure exactly how many moons these planets have. The numbers they have are based on predictions from our current information and from our current technology. You can also see that Jupiter and Saturn have many more moons than any of the other planets. Maybe you could use what you know about those 2 planets that explains why they're the ones that have the most moons. As new technologies are developed, scientists will be able to gather more information that will tell them exactly how many moons these planets have. Today, we're going to explore more about Earth's moon. In 1969, 3 astronauts, Neil Armstrong, Buzz Aldrin and Michael Collins, were the first people to successfully land on the moon as part of a space mission called Apollo 11. as Neil Armstrong took the first human steps on the moon. You might have heard that he famously said, "One small step for man, one giant leap for mankind." It was such an historic achievement for the human race that it was televised all around the world for people to watch. Following Apollo 11, there were several more space missions to the moon. The last moon landing was in 1972. Between 1969 and 1972, all the astronauts that landed on the moon carried out experiments, made observations and collected samples that have helped scientists to understand more about the moon. And it's because of those experiments, observations and samples being brought back to Earth that we know that the moon, well, it's approximately 384,400 kilometres from the Earth. Scientists were able to calculate that because it took the Apollo mission 3 days to travel from the Earth to the moon. Wow! That means the spacecraft they were travelling in was going at a speed close to 5,339 kilometres per hour? That's nearly 6 times faster than an A380 aeroplane. The moon is made of rocky material. Scientists know this after analysing the samples brought back from the moon's surface by the astronauts to Earth. The moon is 4.5 billion years old. That's older than the oldest dinosaur. Scientists were able to determine that after conducting experiments on the moon rocks with samples once again brought back by the astronauts. The surface of the moon has observable features just like Earth. It has craters, lava plains, mountains and valleys. The astronauts made these observations from their spacecraft in orbit. Now, there's no life on the moon. While they were on the moon, the astronauts found no evidence of anything living there or anything ever having lived there. One reason might be the moon has no atmosphere. Earth has an atmosphere. It's the air we breathe. But with no atmosphere on the moon, it means the rocks there have been exposed to the sun's radiation for all those billions of years. The moon is incredible. I wonder how much we will learn about the moon in the coming years as our technology continues to improve. All right, let's recap on what we've learned today. We know that not all planets in our solar system have moons. We know that Earth has one moon and that it takes 27 days to go round the Earth. And that space missions have helped scientists to understand the moon because of experiments, observations, and rock samples collected and brought back by astronauts. Now it's your turn. Over the next few weeks, you might like to look for the moon in the sky and draw the shape of the moon that you see. You could do this for a month and keep it in a scientific journal. And you could teach someone 3 interesting facts about the moon. Thanks for watching and see you next time.
Thanks, Brett. Well, that brings Learning at Home TV to an end for this morning. But we have lots of interesting information to think about this afternoon and some tasks too. Don't forget that we're on air on 7/2 every Monday, Wednesday and Friday from 8:30 a.m. It is time for me to say goodbye, but stay safe and positive and make sure you look out for each other. Remember those health messages and practice those movement exercises our special guests showed us today. Bye-bye.
Authorised by the Queensland Government, Brisbane.